Hello and good evening. So today, I want us to solve or decompose this equation into partial fraction, and we're going to use case one in our case here. So when the first step will be is to factor the denominator into the distinct linear factors. So remember, when you're decomposing with case, we're doing the decomposition using case one. The denominator is made up of a product of two distinct linear factors. So in our case here, our equation is x no, sorry, negative x squared plus 30 minus 56 into bracket over x into bracket x minus 7 into bracket x plus 8. So that's that's our equation. So the next step will be is to set up the decomposition. Since we have two distinct linear factors, we set up the our problem, which is a negative x squared plus 30x minus 56 over x into bracket x minus 7 x plus 8 into two separate fractions, each with a constant numerator. And in our case here, our rational fraction can be written in the form of negative x squared plus 30x minus 56 plus x, sorry, minus 56 into bracket x over x into bracket x minus 7 x plus 8, which equates to a into bracket over x plus b over x minus 7 and plus c over x plus 8. Now, so we already have our rational fraction. So the next step will be is we will multiply the rational fraction with the least common multiple, so that we can now form an equation from our fraction. Now, if we multiply this equation using the least common multiple, now in our case here, we'll do that so that we can solve the resulting equation for a, b, and c. And if we multiply, we'll find our equation here being x minus 2 squared, x, so negative, it should be negative x squared. So this should be this should be just quick one, this should be negative x. This is negative x, so it's negative x squared plus 30 30x minus 56 minus 56. So this equates to this one equation here on the right hand side. Now, so after we've multiplied our rational fraction with the least common multiple in order to solve in order to form an equation, our resulting equation for a, b, and c. We'll try to now solve the constants of a, b, and c. And in that case, what we do, we find the zero factor of each denominator of our rational fraction, and so that we can find the values of a, b, and c. And hence, we'll substitute x equals to 0, and x is equals to 7, and x is equals to negative 8. So this one will be x equals to negative 8. Sorry, that was just writing error. X equals to negative 8 here. And in that case, you will I'll call it Roman 1. In our first equation here, we let x equals to 0, and we'll find our value of a being 1. Now let's solve for b, and we let x be 7. And if we substitute from the left hand side and right hand side, we'll get the value of b being equals to 1. And we solve for c in our third in Roman 3, and if we let x be -8, that when we're solving for c, and in that case we'll find the value of c being c is equals to -3. Now, after we've written all these, we've found the values of a, b, and c. After, because that was the thing. Remember here we said to find the zero factors of each denominator, our rational functions of our rational fraction, we need to find the values of a, b, and c, and we've already find the value of a, b, and c. A being 1, b being 1, and c being -3. So what we'll do, we'll try to go back to our rational fraction, which was, remember our rational fraction up here. Here it was -x squared plus 30x minus 56x over x into bracket x minus 7x plus 8, which is equals to or equivalent to a over x squared plus b over x minus 7 plus c x plus 8. So we already have the values of a, values of b, and values of c. And that will mean that -x squared plus 30x minus 56 over x in bracket x minus 7 plus x plus 8, if we